Today, I'll present our paper, which is Computer Vision to the Rescue: Infant Postural Symmetric Estimation from Incongruent Annotations. Bilateral postural symmetry plays a key role as a potential risk marker for autism spectrum disorder and as a symptom of torticollis in infants. It is commonly defined that symmetry occurs if the angle between two corresponding limb parts differ by less than 45 degrees. So in our paper, we propose a computer vision method for assessing infant postural symmetry from images based on 3D human pose estimation, domain adapted to the challenges setting of infant bodies. Inspired by the definition of postural symmetry, the directly way that we address is using infant pose estimation technology to assess symmetry by supervised learning of human assessment knowledge. The symmetry of each limb is determined by the formed angle of a given limb pair based on the skeleton in infant image is less than some fixed predefined angle theta. However, there exists some practical challenges. First is postural symmetric should be judged in 3D space, but there is no reliable 3D infant pose model or data because of privacy and security consideration. Another challenge is low inter-rater reliability at human ratings of angle and symmetry due to personal intuition and cognition. So to overcome these two challenges, we bootstrap from semi-reliable information. For the weak ground truth data, we use 2D 3D alignment annotation tool to correct the predicted pose inferred by the 3D pose estimation, and then leverage the weak ground truth to fine-tune our infant pose 3D pose estimator. And on the other hand, to solve the human rating reliability problem, a maximum a posterior estimator is proposed to jointly learning the likely to underlying label and the iterator's intrinsic accuracy. Finally, we produce our Bayesian aggregate guided 3D pose-based symmetry assessment. In order to evaluate the performance of human rating and pose-based symmetry measurement, we applied them a publicly released synthetic and real infant pose data with 700 images and conducted an online experiment study to collect the pose-symmetric judgment responses of these 700 infant images from 10 raters. Here we display receiver operating characteristic curves for logistic regression of the Bayesian aggregate angle class and the symmetries from the listed predicted or ground truth source across all pairs of limbs in our images set. We observed that the regression based on our weekly 3D ground truth yields better result, while the 3D infant pose estimation model performs better than the other estimation models or the 2D ground truth. Thank you for your listening.